I'm Mrs. Quint, and we are going to talk today about turning repeating decimals into fractions. I'm going to show you some really cool tricks to do that. Okay, so this number right here is a repeating decimal. I know that because it uses ellipses here, and I actually should have only put 3 because 3 is the correct number of periods that you put to create an ellipse. So this is one way to represent it. You could also say this was 0.4 repeating because only one number is repeating. Okay, now there's a way to turn this into a fraction, but it requires a trick. So you may need to stop and pause this and rewind to see this trick out all the way. So I know I did when I first saw it. So what we're going to do is we're going to use an algebra trick in order to do this. Okay, so I'm going to take the number here and I'm going to set it equal to x. Okay. Now, what I'm going to do next is I'm going to multiply both sides of the equation here. So if 1x, let me just write this down, 1x is equal to the number we're looking at, 0.4 repeating, then 10x would be 4.4444 repeating. Okay, now I represented 4 places after the decimal place here. Of course, I can write as many 4s as I wanted to, but I just matched the amount that I put here. So when I multiplied x by 10, what it meant was I pulled the decimal place to the right by 1. Okay, so this is the trick that I have here. Now, what I'm going to do next is I'm going to line them up like a subtraction bar. So I'm going to have 10x. We know that that's equal to 4.4444 repeating. And I know that 1x is equal to 0.4444 repeating. Again, I could just fill this page with 4s and it would still be the same thing. Okay, so this is the subtraction. I'm going to line up the left side here and the right side here. So what I'm basically doing is I'm subtracting the left sides here, and I'm going to subtract the right sides here so that I can get another equation. Okay, so 10x minus 1x is 9x, right? We know that from algebra. 4.444, so just imagine these 4's continue on and on and on and on forever. It's the tail of this number here. Now 4 minus 0 is just 4. And when you start to subtract these 4's out, what's going to happen is 4 minus 4 is 0. 4 minus 4 is 0, and so on. So what happens is you get all these, all the tails of these subtract off. So you just have 9x is equal to 4. So because all of this tail was eliminated by all of this tail, so you're just subtracting it off. So here you have this very simple algebraic equation that's easy to solve. You just divide both sides by 9, and here you have x is equal to 4/9. Okay, if I had a calculator here, so let me pull up my calculator. I could check myself by saying 4 divided by 9 to get 0.4 repeating. So this is how this is how I could check myself. Okay, so 0.4 repeating is 4/9, and you're going to see a pattern with these 9's here. All right, let's see if we can do it with 2 numbers repeating. So again, we're going to start with that this is equal to x. Instead of multiplying it by 10, okay, and again, I just chose to put it on the right side. It's okay if you do that, or you put it, I mean, I could have also put it on the left side. Maybe you're more comfortable with that, so let's try that. Now, instead of multiplying by 10, I'm going to multiply by 100. Now, I say 100 because there's 2 numbers repeating, so I want to bring both of these numbers to I want to bring 2 and 3 both to the right of the decimal place. In order to do that, I'm going to multiply by 100. So 100x is going to be 23.2323 and so on. Okay, and 1x again was that 0.2323 and so on. So I'm going to subtract the left hand sides. 100 minus 1 is 99x. And that's, again, look at the tails. The tails are identical, right? This 232323 is going to subtract. When you subtract one from the other, you are just going to have those tails, and they're going to eliminate each other. So what you're going to have left is just the whole number 23, because all those tails, they subtract off to get 0.000 and so on. Okay, so you have 99x is equal to 23. Well, that makes x equal to 23 over 99. And again, I could check it here. So 23 divided by 99 is going to get you 0.2323 repeating. Okay. Finally, if we have 3 or more numbers repeating, same trick here. We're going to let this equal to x. Instead of getting 100x, we're going to get 1000x. That's going to help us here. So we'll have 356.356 all repeating. Okay. Remember, multiplying by 1000 draws the decimal place over 3 times. Okay, so it would be right there. Oops. Okay, so we know that 1x is still equal to 0.356356 and so on. 1000 minus 1 is 999x. That's equal to 356, right? So those tails eliminate each other. So x must be 356 over 999. So what you'll notice here is that if 3 numbers repeat, it's going to be over 999. If 2 numbers repeat, it's going to be over 99. And if 1 number repeats, it's going to be over 9. Okay, so that's your pattern here. Now, if 4 numbers repeated, you could think, well, let's see, 0.4567, 4567, and so on. Then I could easily transfer that to 4,507 over the amount of numbers that repeat. I use that for the amount of digits I need in with my 9s here. So it would be 4,567 over 9,999. Okay, and I could check that here. And there we go. 4567, 4567, 456, and so on. Okay, now what happens if only one, not all the numbers repeat? So here we have 0.256 and so on, but the 6 is the only number that repeats. So if you were to write this in with the bar notation, the bar would only be over the 6 and not the 25. So you do here. Well, again, we're going to set this equal to x. Okay, and we're just going to have to do a few tricky things here. Okay, so it's only going to make, I'm going to show you how to do it, and then I'm going to do it, and then I'm going to show you why I did it. So first I'm going to find 1000x. Again, just watch me as I do this, and then we'll talk about why this trick worked. Okay, that's 256.6 repeating. And then I'm going to find 100x. Okay, and let me make sure to line this up. This is 25, and then again the tails are the 6s. Okay, the reason why I didn't use x in here is because I wouldn't have identical tails, and I want to get identical tails because then when I subtract them, all of these tails go away. Okay, now 256 minus 25 is 231, and that's going to be equal to 900x. And here again we have our simple equation that we can solve, and so that's it. X is 231 over 900. Now what I did was, again, I wanted to use powers of 10. I want to multiply x so that the tails of the 2 numbers that I'm subtracting are identical. You could have used 10,000 and 1,000. It wouldn't matter that much. You'd actually still get the same thing in the end, as long as you can eliminate those tails. So that was our whole goal. And if you checked it, 231 divided by 900, you're going to get. So here you see the 25, the 0.25, and then the 6 repeating. Remember that 7 is because the calculator is anticipating a 6. And so it's rounding this last digit as a 7. Be very careful when you interpret information on a calculator. This last digit is either, it can be a rounded digit. In our case, we know it's a rounded digit because this is the number that we used in order to, we used the number 0.25 with 6 repeating. To get 231 over 900. Okay, all right, and that's it for today. Thanks.